seeing it there. It says excellent connection. We're not seeing it. There it is now coming up. Alright, ready? Alright, so we're going to solve these problems by substitution. And that's a method that we investigated on the last occasion. So the first one, of course we have the introductory audiovisual for this, and now we are just doing the classwork, because this is the classwork. Now we have a set of problems to solve, and I'm taking a look at the odd numbers because we will leave the even numbers for you to do for your homework. Alright, so let's just continue. It's just a continuation of the previous audiovisual. So we are going to say from equation 1, what? X is equal to, and we're going to transpose. X is equal to what?
X is equal to
7. What else? We're making X a subject there. Minus 3y. And that is your equation 3. So we're saying X is equal to 7 minus 3y. From here, we are writing X in terms of everything else. Right? And we're going to take this and we're going to substitute that into equation 2. So we are saying X is equal to, and we are going to eliminate this 3y by subtraction. So it's going to be 7 minus 3y. And then we're going to substitute that into equation 2. So where we see X, we put 7 minus 3y. So let's go. 2 times X. 2 times 7 minus 3y minus 2y, and that is equal to 6. So 2 times X is 7 minus 3y, then we minus 2y, and that is equal to 6. So the only thing that is different in this is the 7 minus 3y, which of course we know to be X. So we just expand these brackets, so we have what? 2 7s, 14 minus 2 times negative 3, so that's going to be negative 6y minus 2y is equal to 6. So we're going to put those together. Negative 6y minus 2y, that will give you negative 8y. And that is equal to, we are going to have what? This 14, we're going to eliminate 14 by subtraction. So it's going to be 6 minus 14. And that will give us what? 6. Right, negative 8. So that's negative 8. So in this case, y is equal to negative 8 divided by negative 8. And that is equal to 1. And we're going to put that all the time, as much as we can, into equation 3. We put that into equation 3. We see what the answer is equal to already. Because it's going to be 3 times 1, which is 3, and then it's going to be 7 minus 3, so x is equal to 4. So when we put that there, we get x is equal to 7 minus 3 times 1. So x is equal to 7 minus 3, which is equal to 4. And then we will just say x is equal to 4, y is equal to 1. Now, let us change it to this one. Hopefully it's right, it's better. Now, what are we going to do here? I think that we could just substitute 2x for 2x. That seems reasonable. So, we're going to say from equation 2, what do we say? 2x is equal to, what do we say? Now, this 2x is going to be eliminated by addition, so we'll have a positive 2x here. The 3y will remain, 5 is going to be eliminated from this side by subtraction. So it's going to be positive 2x is equal to 3y minus 5, because this 5 is going to be eliminated and be a subtraction. Subtract 5 here, okay? minus 5, and that is our equation 3. And we are going to put this into which equation? Into equation 1. Now, in equation 1, where we see 2x, we put 3y minus 5. 2x is equal to 3y minus 5. So here is 2x. So this 2x is 3y minus 5. So we have 3y minus 5, that is 3x. Then we minus y, and that is equal to 1. So this is here 2x, which is 3y minus 5. So 2x is 3y minus 5, 2x there, 3y minus 5. Then minus y, and then that is equal to 1. So that works out very simple, because we're going to have 3y minus y, and that will give us 2y. And then we have a 1 here, and we will eliminate this negative 5 by addition. So it's going to be 1 plus 5, which will turn out to be 6. So y will be equal to 3. And that will put into we will put that into which equation? We could put that into equation 3. So I might want to put it into equation 1. I put it into equation 3, and what will we get? 2x is equal to 3 times 3 minus 5, because y is equal to 3. So 2x is equal to 3 times 3 minus 5. So 2x is equal to 3 3's minus 5. So x is equal to, right, so x is equal to 2 while y is equal to 3. We could do the same trick right here with the 3y. Substitute 3y for 3y and see if it shortens the working. So we're going to go again from 2 what? 3y is equal to, so 3y is going to be positive. Then we're going to say eliminate by subtraction. So 2x minus 6. So from here, 3y and then 2x minus 6. So that's going to be positive 3y is going to be 2x minus 6. And we're going to put that into equation 1. So the first thing that we have in equation 1 is x. So we put x. Next thing we have is 3y. 3y is 2x minus 6. So where we see 3y, we can put 2x minus 6. Plus 2x minus 6. And that is equal to 12. X plus 2x. That will give you 3x. And then this negative 6 will be eliminated by addition. So added here is equal to 18. So x is equal to, and we're going to put that into equation 3. So we put that into equation 3, which is this one. We have 3y is equal to 2 times 6, because that's what x is, 6. 2 times 6 minus 6. So 3y is equal to what? 2 6's minus 6. So y is equal to we have 2 more. Two more of your favorites. Hopefully, we'll have that's nice. So yeah, we're going to take a look at the other 2. I'm going to erase this so we can have them while on the board. Well, I'm going to put the other one, put one on the board first and then we do what's necessary. So we'll have 2x plus 3y is equal to 1. Number 7, 2x plus 3y is equal to 1. And 5x plus 3y is equal to 16. 5x plus 3y is equal to 16. So that is your equation 1. And that is your equation 2. So 2x plus 3y is equal to 1. 5x plus 3y is equal to 16. And we're going to put number 9 on it, which is of course the last one that we're going to be doing. So number 9 will go up also, which says x minus y is equal to negative 2. I love this one. Number 9 is my favorite. And it says x minus y is equal to negative 2. And that's equation 1. And it also says that 2x plus 3y is equal to 21. 2x plus 3y is equal to 21. I like these final 2. They're nice. So what are you going to say in that one? From which equation are you going to say? From, it's a long time since we have taken from equation 1. From equation 1, and we're going to use 3y again. So 3y is equal to, easily in this case, 1, and then this 2x we're going to eliminate that from that side by subtraction, minus 2y. So it's going to be 3y is equal to 1 minus 2y, and that is your equation 3. From 1 we put into equation 2. And what do we get? We are saying 2x will go first, so 2x goes first, please. 2x goes first, then plus 3y. Plus 3y. What is 3y? We are going to put it into 2. If we are putting into 2, we are going to start with 5x. We are putting that into equation 2. So putting that into equation 2, we are going to say 5x. Then we're going to put 3y. What is 3y? One minus 2y. Let's go back to this. Because 3y cannot be equal to 1 minus 2y. Let us correct that. What should that be? 3y is equal to 1 minus what? That's not it. 1 minus 2x. So from here, 3y is equal to 1 minus 2x. That's correct now. Then we're going to put that into equation 2. Putting that into equation 2, we have 5x plus 3y. What is 3y? 3y is, so 5x plus 3y. 3y is 1 minus 2x. 1 minus 2x. And that is equal to 16. And that is that number. So 16. So we're going to put those together. What do we get? 5x minus 2x. What's that equal to? 3x. And of course we have a 16 here. And we have a 1 there, plus 1. We're going to eliminate this one by subtraction. So it's going to be 16 minus 1, which is 15, which will cause x to be equal to 5. And that we are going to equation 3, what do we get? 3y is equal to 1 minus 2 times 5. So 3y is equal to 2 5s, 1 minus 10, negative 9. Y is therefore equal to negative 3. So x is equal to 5, y is equal to negative 3. And here's your favorite, my favorite also. What do we say about that one? I'm going to say early from 1. From 1, what do we say? I have a feeling what you will say, but I will say something different, I think. From 1, what do you say? Do you say x is equal to or y is equal to? And what will x or y be equal to? I'm looking at, yes, you're going to be saying y is equal to. I would say y is equal to. And what is y going to be equal to? You're going to say y is equal to. And I'm going to say y is equal to. Now, if we're going to do that, this y will be eliminated by addition. And this negative 2 will be eliminated by addition. So we'll have x plus 2. We have x plus 2. I prefer to do this than anything else. Why? Because in this case, look at this. Everything positive. And we're going to put that into an equation if everything is positive. So there's a great chance that we'll never see another negative sign in the solution of this system of equations, which is good. Right? So by this substitution, by doing the right substitution, then we will not have any negative sign again, which is ideally what we want. So this is your equation 3, which is your favorite, of course. And we are going to put that into equation 2. So we say 2x plus 3y. And what? 2x plus 3y. What is y? Y is x plus 2. X plus 2 will go there. And then that is equal to 21. Nice. So we may go straight ahead. 2x plus 3 times x, 3x. 3 to 6. And that is equal to 21. So 2x plus 3x, that will give you 5x. And what do we do with this 21? We have a positive 6 to be eliminated by subtraction, right? So this positive 6 will be eliminated by subtraction. So we will have 21 minus 6, which is 15. So x is equal to into 3. And of course, this is the reason for putting our equation 3. Look at this. X is equal to 3, correct? Put that 3 here. What is y equal to? Alright, so if we put that 3 here, y is equal to 5 and we are done. So we put that into equation 3, we get x is equal to, not x, y is equal to y is equal to x is what? 3 plus 2. So y is equal to 5. Therefore, we finish up by saying x is equal to 3 and y is equal to 5. And that's all there is to it. Right. So I am sure that we have some nice takes on the solution of a pair of simultaneous equations, and we are using the method of substitution. Not only that, it is not a typical solution. Sometimes we'll just maybe not use this or maybe divide by 3, but we are taking advantage of the fact that we have a 3y here and a 3y. So we can substitute 3y for 3y. Okay? Which is nice. Yes. And in this case, it is not a case like this or even number 5, but we are taking advantage of the fact that if we do the right transposition, all the negative signs will go away. And as a matter of fact, see, for the entire time, or for the rest of the solution of the equation, we did not encounter any more negative sign as soon as we made this switch, which is to take this and make y the subject of the formula. If we made x the subject of the formula, then we'll have to carry this negative 2 to the end. But just by making y the subject of the formula, we had all positive terms to the end. And when we're solving any problem at all, then we should take advantage of things about the problem that makes the problem simple, or what we call a loop of simplicity, or we can take an approach that, yes, sometimes it is said that we should what? Cause a problem to solve itself. Right? And that is what we are doing when we substitute 3y for 3y. So that's all there is to it. Those two we see. Okay. So before we go away, that one is all the way over there. Right. So although we are at the end, it is good to give recognition to someone who is present right there and also partaking of this exercise. So goodbye until our next audiovisual, which quite likely will bring to an end the entire episode and on algebra for this